And now for momentum questions 6 to 10. In number 6 we have another example of things hitting and sticking together. So M1 is 2,000 kilograms. U1 is 9 meters per second. M2 is 1,500 kilograms. U2 is 8 meters per second. And they're travelling in the same direction, so they're either both are positive or they're both negative. Ideally, if it's to the right and upwards, or to the right or upwards I should say, it's positive. If it's to the left or downwards, it's negative. That's the easiest way to avoid getting yourself stuck with whether it should be plus or minus. So, in the absence of external forces, total momentum before collision equals total momentum after collision, and then we go M1U1 plus M2U2 equals M1 plus M2V, because they're sticking together, so we use the sticking together version of the formula. Stuck together after the collision times 9.0 plus 1,500 times 8.0 equals, well, 3,500, because if you are struggling to do 2,000 plus 1,500 at this point, you have bigger problems than physics. So that will be 18,000 there, plus 12,000 there, equals 3,500 V. So V is 30,000 over 3,500, which is 8.57 meters per second. Now for number 7, we have got M1 is 1,400 kilograms, M2 is 1,000 kilograms, U1 it says is 20 meters per second, U2 is 30 meters per second, V1 is 25 meters per second, and since we get separate V1s and V2s, we can deduce that this is not sticking together. So in the absence of external forces, total momentum before collision equals total momentum after collision, and then we can go M1U1 plus M2U2 equals M1V1 plus M2V2. Let's not forget that's just part A. So plug the numbers in. 1,400 times 20 plus 1,000 times 30 equals 1,400 times 25 plus 1,000 times V2. So that will give us 28,000 there, 30,000 there, 35,000 there, plus 1,000 V2. So V2, we add that and that, we get 58,000. Take that over to the other side, so minus 35,000. 1,000 V2, we only want one V2, so divide it by 1,000. So V2 equals 23 meters per second. Now for part B, we're once again EK before and EK after. So EK before, a half M1U1 squared plus a half M2U2 squared. Plug in the numbers. A half times 1,400 times 20 squared. Don't forget the squared, that's the usual way people get this wrong. Times 1,000 times 30 squared, and that should all end up being 730,000 joules. And then the EK after, a half M1V1 squared plus a half m2v2 squared, that's a half, times 1400 times 25 squared plus a half times 1000 times 23 squared should give you a total of 702,000 joules, and therefore EK is lost, so it's an inelastic collision. And for number 8, it gives a slight twist on things. This time they're going to give us all the initial data. They're going to give us the final velocity for mass number 2, but they're not going to give us the final velocity for mass number 1, which means we must be working out the final velocity for mass number 1. So it's going to be exactly the same as previous questions. We're just working out V1 instead of V2. So mass 1, 1200, mass 2, 800. Initial velocity of mass 1 is 10 meters per second, according to the question. Likewise, the initial velocity of mass number 2, according to the question, is 9 meters per second. In the same direction, so they're either both positive or both negative as before. I've just decided to make them both positive, assuming that they're both going to the right. And you should be able to deduce that this one should eventually catch that one, because it's going faster, and that's why there's a collision. So V1 is some value we don't know, and V2 is 11 meters per second. So it looks like there's been a transfer of momentum from this object to this object to cause it to travel faster. So total momentum before collision equals total momentum after collision in the absence of external forces. Remember, you're writing that down if it's in an exam or a test. Okay, so M1U1 plus M2U2 equals M1V1 plus M2V2, because they're not stuck together, because they've got different velocities after the collision. Plug the numbers in. 1200 times 10 plus 800 times 9 equals 1200 times V1 plus 800 times 11. That should give you 19,200 on the left hand side equals 1200 V1 plus 8,800 on the right hand side. So V1 should equal 19,200 minus 8,800 divided by 1200, and that should give you 8.67 meters per second. Number 9. First mass is 0.8 kilograms, 800 grams, 0.8 kilograms. Second mass is 1.2 kilograms. Initial velocity is 1.5 meters per second. To the left, from right to left. We need to think about that later on. Initial velocity for mass number 2 is 2 meters per second from left to right. So if it's going from right to left, that's going that away. That's leftwards. So I'm going to stick a minus sign in there. If it's going from left to right, that's positive. That's that away. I'm going to leave that as positive. And apparently these things stick together after the collision, so what velocity are they moving with overall? Right, let's bung the numbers in and see what we get. After, of course, writing down total momentum before collision equals total momentum after collision in the absence of external forces. So M1U1 plus M2U2 equals bracket M1 plus M2 close bracket V. So it's 0.8 times negative 1.5 plus 1.2 times 2.0 equals 0.8 plus 1.2 times v. So that's negative 1.2 plus 2.4 equals 2.0 v. Negative 1.2 plus 2.4 is a 1.2 equals 2.0 v. So v must equal 0.6 meters per second, and it's positive, so that must be left to right. There we go. So far so good. If you had decided to make that positive and that negative, in other words, you use the opposite convention for the directions, you would have a plus 1.5 there, a negative 2.0 there, which would mean you had a negative 1.2 here, which means you'd have a negative 0.6 meters per second there. But since you had swapped the conventions over, it would still be left to right. It would still work. So good. As long as you don't mix and muddle your positives and negatives, it should all be fine. And lastly, number 10, we are given mass of the first one, 0.2 kilograms. Mass of the second one is 0.12 kilograms. Velocity of the first object, 10 meters per second. Velocity of the second object after the collision is what we're apparently trying to find. The initial velocity of the first object is 0 meters per second. And the initial velocity of the second object is 0 meters per second. How do I know this? It's because it's an explosion. Which means that the total momentum before the explosion, when everything is just sitting in the one piece, minding its own business, is 0 equals m1 v1 plus m2 v2. Now this basically tells us that the momentum of all the parts of whichever object exploded have to sum back to 0. Now, only 2 bits in a nice simple question, just demonstrate you understand the concept. In a real life thing, there'd be hundreds of bits. So bomb technicians, when they have to go and reconstruct explosions to find out what happened, have a real healthy dose of momentum to be doing, because they've got all sorts of many dozens or hundreds of masses moving in 3 dimensions. You've only got 2 moving in 1 dimension. Basic principle is the same, but the calculation in the real world is a lot more complicated. So 0.2 times 10 plus 0.12 times v2. So 0 equals 2 plus 0.12 v2. So it should be obvious that v2 is negative 2 over 0.12. Where did that minus come from? It came from taking the 2 over to the other side, which equals negative 16.7 meters per second. Why negative? Because it's got to be going in the opposite direction. There we go.